So good morning, everybody. So today we are going to proceed to new chapter, which is probability. Okay, and I'll divide this session into three parts. The first part, I'm going to introduce to you the basic concept of probability. Okay, then we'll proceed to different types of events, which consist of mutually exclusive, independent events, dependent events type of examples. Okay. And for dependent event type of question, you may need to use Venn diagram and also the tree diagram to help you to solve the problem. So generally, there are three parts for this chapter. Okay. Okay. So what is the meaning of probability here? Actually, probability is referred to chance of an event happens. Okay. So this event here can be referred to issue, can be referred to activity, can be referred to phenomenon. Okay. And what's the reason we want to study probability? Because we want to quantify chance of an event happen. We want to quantify. Okay. So generally, what is the symbol we use to represent probability? Okay, you can use P. You can use capital P. I think in your school you use P, right? Capital P. Okay, or you can use PR to represent probability. Okay. So if you want to calculate probability of event A happen, then you can put PRA. Okay, A means the name of the event, event A. So what is the formula to calculate the probability? Okay, the formula is like this. It's using NA divided by NS. So you may find that there will be two layers, right? Two layers. So the numerator here is referred to number of elements from event A. Okay, and NS denominator is referred to number of overall sample space in a defined group of study. Okay, you may really know now you have a doubt. What is the meaning of sample space? Or what is the meaning of element here? Okay, let us try one example later on. Okay, bear in mind your probability value. Any probability value should be between 0 to 1. Okay, the probability value can be equal to 0 exactly, can be equal to 1 exactly also, but cannot be negative number. Cannot greater than 1. All right. So if your probability A, event A is equal to 0, what's the meaning? That means event A confirm is not going to happen. Okay. Event A is not going to happen. That is the meaning. 0% event A will happen. Okay. What is the meaning if probability A is equal to 1 exactly? That means event A is going to happen. It's guaranteed to happen. Or we can say that event A is 100% going to happen. Okay, confirm, very certain. Okay, if your probability A is equal to 0.7, what is the meaning? That means like event A has 70% of chance to be happened. Okay, 70% chance to be happen. Okay, how to get 70%? That is 0.7 multiplied 100%. Okay, but anyway, when we do calculation, the probability value must always between 0 to 1. Between 0 to 1. But when you want to do some interpretation, then you can try to use percentage. All right. But when you do calculation, we always use the number between 0 to 1. So far, so good. So these are the basic concepts that you must understand first. Okay. Basic understanding for the concept of probability. Okay. Okay. The probability event A plus probability non-A event always equal to 1. Probability non-A here, I use the symbol A bar. A bar. It means complement of event A. Another word to represent P A bar means complement of event A. Complement of event A. So probability of event A plus probability of non-A always equal to 1. Okay, always equal to 1. So if you are asked to calculate the probability non-A, what you can do is you can use 1. Then minus probability A. Then you can get the probability non-A value. Okay. I can also use a Venn diagram to represent the relationship between A, non-A, and sample space. Okay. So sample space is referred to all of the elements possible in the activity. So it can be representing by using the rectangular. So as the whole thing, the beige color one, this yellow thing is S. Okay. All of the possible outcomes. or we call as sample space. Okay, so property A, it can be here in the circle. Okay, any elements inside the circle are considered as event A. Okay, so how about outside the area of circle? That will be none A. Okay, so none A is this area, the yellow area. Okay, the whole thing here, the blue plus the yellow will be the sample space. Okay, so let's try one example. All right, so let's try one example to try to understand the meaning of probability. All right, so let's say now we want to do one experiment. Okay, so the experiment is we want to throw a fair die. Fair die is something like this. This is a die. All right, example of die. Okay, I have also this. Okay, can you see this? This is not a fair die. This is just a toy. It's not fair. Not fair means like the chance to get either score 1, 2, 3, 4, 5, 6, right? All will be not equal because this is not a fair dice. Not equal. All right. Then, okay, let me check whether I have a fair dice or not with me. Fair dice. Yes, I have fair die here. All right. This is fair die. Why? Because chance to get either score 1, 2, 3, 4, 5 will be the same chance. Okay. The chance to get score 1, 2, or 3, 4 will be 1/6. So how to get this value then? Okay, how to get this value? Okay, it's like this. Okay, we have to understand first the characteristics of the object that we want to study. Okay, so a dice consists of how many faces? We have this one. Score 1 means is considered as one face. Okay, it's a face. Then we have score 2. This is score 2. Score 3, this one. Right? Score 4 here. Score 5, this one. Score 6 here. So in total, a die consists of 6 faces. Okay, consists of 6 faces. So we can say that, right? Sample space is equal to 6 for a dice. For this question, for a dice question, the sample space is 6. Okay, because we have score 1, 2, 3, 4, 5, 6. So that means that your NS is equal to 6. Okay, so if you want to solve the problem for a dice question, your NS is 6. Okay, so I can conclude the number of possible outcomes, okay, for a dice is 6. So this I put NS equal to 6. All right. So I use purple color. Okay, because of score 1, 2, 3, 4, 5 until 6. So your NS is equal to 6. So far so good, All right. So let's try question A. Okay, part A. Okay, what is the probability? You'll get score 6. Score 6 means this one. Okay, this one, Okay, so we know that probability value always consists of 2 parts, 2 layers. All right. Because our experiment is a die. As a result, your denominator must always equal to 6. Okay, denominator is always equal to 6. Why? Because in total, a die consists of 6 faces. Okay, and S is 6, so you put 6 here. Okay. Okay, now we go to the numerator. Numerator is referred to how many faces consist of score 6. Only one face has score 6. Okay, only one face. So as a result, the numerator is 1. So I use green color. Okay. So answer is 1/6. Because this fraction number is the simplest fraction number, so you can leave the answer like this. Because if you leave the answer in decimal number, it's a continuous number. You'll get like 0.6667, right? That will be continuous number. So it's better for us to leave the answer in fraction number. Okay, so the answer is 1/6. Okay, one example is not enough. So let's try another example. Okay, what is the probability? Even number will be obtained. Even number. What is the meaning of even number here? Even number means any number can be completely divided by 2. Okay, even numbers means the number that can be completely divided by 2 is even number. Okay, so example of even number will be 2, 4, and 6 in this case. 2, 4, and 6 are even numbers. So let me write down first the even numbers. Okay, even numbers I use I put somewhere here. Okay. So even numbers. So I move to somewhere. This I use green color. So the even number can be 2 and 6. Okay. These are the possible outcomes for even number. So there are 3 possible outcomes, right? Either 2, 4, or 6. Okay. So the numerator here you can put 3 for this question, because a dice consists of only 3 faces with even number, which are face this one, okay, 2, score 2, score 4, and score 6. Okay. So numerator you put 3 possible outcomes for even number. And then how about the denominator? Denominator, because this experiment is only involve a die. Okay, a die consists of 6 faces, so denominator is 6. Okay, so this number can be simplified again. This fraction number can be simplified. Okay, if you simplify by using calculator, you can use 1 and then press ABC button followed by 2, followed by 6 and then press equal button. You'll get 1/2. Or you may leave the answer in decimal number, because it's a finite. Decimal number, you'll get 0.5, also acceptable. Okay, so you may leave the answer in fraction or decimal number. Okay, I stop for a while. Any questions so far? So far okay, yeah? So far so good. So now we are only using this formula, yeah? Using this formula, okay? This formula to calculate probability for event A. So just now for sample, for second question, the event is looking for even number. Probability, the dice will show an even number. Okay, so you can use formula. So your number of even numbers from a die consists of three even numbers, which are 2, 4, and 6, right? And then NS is referred to total faces. Okay, total number of faces from a die. Okay, so a die consists of 6 faces, so NS is 6. Okay, I go back to here again. Okay, next question. What is the probability? Okay, the number that we get is less than 5. Less than 5. Okay, you can see the symbol here. It's not include 5. It's less than 5. That means it's not include 5. Okay. So what are the possible outcomes that will have less than 5 then? Okay, we go back to here again. Okay, you check among these 6 numbers, what are the numbers which are less than 5? I highlight using green color. You may find that there are 4 faces, okay, have scored less than 5. Okay, so as a result, for this question, the numerator is 4. Numerator, that means the upper part is 4. Okay, how about the denominator? Because this is a dice question, okay, consists only one die. One die consists of 6 faces. So the denominator is always equal to 6. Okay, then you can simplify this fraction number. Simplify, you'll get 2/3. Some students may ask, can we simplify by converting to decimal number? Can, but your answer will be 0.66667. Is a continuous number, continuous decimal number. So this may create a rounding error later on. So yeah, it's better to leave the answer in a fraction number. Okay. So C, okay. Okay, D. This question is probability to get score 2 and 4. Okay, confirm is score 2 and 4. Confirm. School 2 and 4. Okay, but don't forget, right? Yeah, that is not possible for us to get 2 scores at the same time. It's not possible. When we throw a dice, it's not possible for us to get 2 different outcomes. Okay, we can only get 1 outcome. If the question asking to get 2 outcomes, 2 and 4, then Not possible. Not possible to achieve. So answer is 0. Because there is no die. Okay, dice has the face of curve dimension. Consists of score 2 and 4. No, there is no 2 and 4. No. So answer is 0. 0/6, in fact. So you can round the answer to 0. Okay. So bear in mind, because this question only involves one die. One die only. Okay. So a die doesn't have any face. Okay. That consists of 2 plus 4. No. Okay. So some students may ask, how about this one? Total. This is not. Okay. The question is asking 2 and 4. Okay. This is 6. Different. Okay. So answer is 0 for this question. Not possible to get this outcome. All right. Okay. Part E. What is the probability? The score is 2 or 4. Okay. 2 or 4. That means it can be 2 or it can be 4. If that's the case, I will have to do step by step. That means there will be involved two terms. Okay, we have to solve the problem for score 2 first. What is the probability? The score is equal to 2. Answer is 1/6. All right. 1/6. Maybe I use other color. I use orange. This is 2. Maybe I use this one. 1. 1 is because of this one. Okay. This is for probability to get score 2. You get 1/6. Okay. Then plus the probability to get score 4. Score 4 also got 1 only. One face or one dimension consists of score 4. I use different color so that you can see. This one maybe I can use. I already use 2 for this one. 4 I use pink color. All right. So this is pink. Okay. 4 is pink. One dimension consists of score 4. So sum out these two numbers. This one is for score 2 probability. This one is for score 4 probability. So because the denominator are the same, 6, so you can combine. You can use calculator to get the answer directly. 1/6 plus 1/6. So answer is 1/3. I stop for a while. So far, the activity that we have done now all only in one object. Only one object, which is a die. Okay, only one object. So far, so good. I stop for a while. Okay, all right. So let us try to apply this formula, the formula that we learned today, this relative frequency rule formula, to apply to some case study, right? So let's try one question here. Okay, this question is 100 people are surveyed to identify their bank. That means the preference bank, okay? Which bank they use to do some maybe business transaction or have the account in the particular bank. Okay, so from these statistics, we know that 20 customers, 20 customers use Bonza Bank, and 26 customers have account in Combank, and 34 customers have account in Neti Bank, and 20 customers have account in Melbank. So in total, we have 100 participants involved in the survey. In total, there are 100 participants in the survey. Okay. Now is next question. What is the probability if we choose a person from this 100? If we choose a person, randomly choose a person from this 100, what is the probability this person is a customer of Combank? Combank. So in order to solve the problem, I can write down the formula first. So the formula is Pcom equals to, if I want to add, I can say this is Ncom, COMM, divided by NS. Okay. This is the formula that we have learned this morning. This is the first formula we learned. Right. Because the formula that we learned this morning is this one. PA is equal to NA divided by NS. So if you want to calculate Pcom, then the formula should be Ncom divided by NS. Okay, Ncom divided by NS. Should be this one, right? Okay, NS is easy. NS is referred to total of participants in the survey, in total. Okay, without consider the bank they visit or they prefer. In total, how many participants in the survey? Altogether 100. So we substitute 100 into here. Okay. So I use per color. Okay. Then because the question is asking for right? Bank, so we need to check. Okay, how many customers prefer to use bank? 26 of them, right? So 26 we substitute here as a numerator. So I use green color. Okay. So far, okay. 26 divided by 100. Okay. You can round the answer to fraction number. Okay. You can try to simplify the answer into fraction number or decimal number. Okay. Because if you round to decimal number is finite decimal number, so you may leave the answer in decimal value. Otherwise, you can simplify. Answer is equal to 13 divided by 100. Also okay, there will be two answers. So it's up to you. You decide. Okay, you decide which number you want to use. Either decimal number or fraction number. Okay, this is fraction number. That will be equal to 13 over 50. Both are accepted. Okay. So far so good. Okay. All right. Now we'll move on to two sections now. Okay. In the real life, not always one event happen. It sometimes can be more than one event happens in the world. Yeah. Just now the two example that we look at, right? We only focus on one event. Okay. Only one event. And now is what happened in the real world if got more than one event happens. Okay. Then we need to understand some concept first before we answer or address the problems that involve more than one event. Event here refer to activities. Okay. We need to understand some basic concept first. Okay. Okay, let us try to check the union rule. What's the meaning of union rule here? That is, okay, property A union B. A union B. Okay. Union here is also referred to all. Okay, in statistics. Union, this U means union. It's also called as all. Okay, all. So what's the meaning of A union B? That is equal to probability A plus probability B minus probability A intersect B. Because why I have to minus this one is because sometimes some of the elements from event A and event B are overlap. Okay, in real world, sometimes the elements, okay, in event A and event B are overlap, which is this part. Okay, so we should not double calculate this part. As a result, we need to minus this part one time, this area, okay, one time, in order to get A union B. Okay, so A union B actually is equal to this part, which is A is here, okay, this round shape, round area, plus B is this round area, okay. Then minus this part because this part is overlap, right? Overlap means that means there will be double calculation. So we need to exclude one part of this one, okay? Because it's overlap, it should not be double calculated. So this is the formula that you need to remember. Probability A union B is equal to probability A plus probability B minus probability A intersect B. Okay. We call this as union rule. Okay. Next. Okay. Mutually exclusive. What is the meaning of mutually exclusive? Mutually exclusive means that two events cannot happen at the same time. Mutually exclusive events means the events cannot happen at the same time, cannot happen simultaneously. Okay. So if I draw the Venn diagram, you may find that the A and B will not intersect. Okay, will not overlap because cannot happen at the same time. So A and B will not overlap. Then we can say that, right? For mutually exclusive events, the A intersect B always equal to 0 because not overlapping. Okay. So the chance to have similar elements between A and B would be 0. Because A and B never intersect for mutually exclusive events. Okay. So A intersect B is equal to 0. Because of this, then we can say that, okay, if we can try to simplify also. So if you want to do some calculation that involve mutually exclusive event, that means like A union B is equal to probability A plus probability B only. Okay, and A intercept B is equal to 0, so you can remove lah. Okay, so you can only remove this part, this term only, when A and B are mutually exclusive. Okay? Mutually exclusive event, then you can simplify your formula for A union B. Okay, so you may ask now, okay, then in real world, how do you know the events are mutually exclusive? Okay, let's try one question here. Okay, first example. Swimming and sitting an exam. So there are two events. The first event is swimming, all right? Second event is sitting for an exam. So do you think these two activities can be run at the same time? Are you able to swim meanwhile answering the question? The online, let's say the online quiz or online test or online exam. Can you do these two activities at the same time? What do you think? Can you? Cannot, right? Can we do swimming and then after that we're sitting for the exam at the same time? Answer is no, right? So these two events cannot happen at the same time. So we can say that these two events are mutually exclusive. Okay, swimming and sitting at exam are mutually exclusive events. Okay. Okay, another example. Rolling score 3 and score 5 with a dice. What is the meaning of this question? That is, if you throw a die, your result is score 3 and score 5. Not possible also. Why? Because if you roll a die, you can only get one result. You cannot have two results. Okay, only one result. Either score 1, 2, 3, 4, 5, 6. You cannot have score 3 and score 5 happen at the same time for one event. Cannot, so this is also considered as mutually exclusive. Okay. Okay. Next question. Next example is living in Kota Samarahan and working in Kuching City. Okay. Bear in mind, for those who are not staying in Sarawak or Kuching, because Kota Samarahan actually is very near to Kuching. Okay. It's just like in KL, it's like Selangor and KL, something like this. Selangor and KL. So possible to live in Kota Samarahan and working in Kuching. So you can consider Kota Samarahan is a rural area, all right? And then Kuching is a city. So it's possible because got road to connect Kota Samarahan and Kuching. Okay, these two events can happen at the same time. As a result, these two events are not mutually exclusive. Okay, just like living in Selangor and working in KL. Can be happen. Okay, so these two events are not mutually exclusive. Okay, so next question, next example, being under 21 years old. Okay, 21 years old, below 21 years old, and become Malaysian Prime Minister. Okay, in Malaysian rule, to become a Prime Minister, okay, the candidate must always greater than 25 years old. Should be 25 years old or equal. Okay, cannot be below than 25 years old. If below than 21 years old, then it's not qualified. Okay, to be nominated as the Prime Minister in Malaysia. So these two events cannot happen at the same time. As a result, these two events are considered as mutually exclusive. Okay, so the rest you can just read through by yourself. All right, next. Okay, independent events. What is the meaning? Okay, so A and B are independent events. If event A will not influence event B happen and vice versa. Okay, if A will not have influence the probability of B happen and B also will not influence the probability of A happen, then we can conclude A and B are independent events. Okay, so occurrence of event A will not influence the chance for event B to happen and vice versa. Then we can conclude A and B are independent events. Okay, so for independent events, we have some characteristics. Okay, so if you want to calculate probability A intercept B, okay, then the formula is probability A multiply probability B. This is only happen for independent events. Right. And if you want to calculate probability A, given that B already happened, this simple slash means given or if. Okay, if or given event B already happened. I use some other color. I use Maybe I use blue color. All right, I use this blue color to represent this symbol. The slash symbol means if, conditional. Okay. Okay, I use blue color. All right, so they can see. Okay. So we start from this. Okay, this formula. All right. I think I better increase the size so they can see. Okay. So this one means probability A given that B already happened. If A and B are independent, that means that B is not going to influence A. Okay. A also not going to influence B. So if we know that, okay, if we know that B already happened, what is the probability A given B? The formula is still equal to probability A. Why? Because A is not influenced by B. Okay, if A and B are independent events. So even though we know that B already happened, but the answer for this is still equal to A because A is not rely on B. Similarly, also for independent event question, if you are asked to calculate probability B, given that A already happened, answer is still equal to probability B. If A and B are independent. Independence means A will not influence B, B will not influence A. Okay, in Bahasa means merdeka. Yeah, merdeka. So let's try one example here. Okay. So any example that we can use to demonstrate the independent events question are yes. What are the example here? It can be throwing 2 coins. Okay, throwing 2 coins. Hold on, I go to get my coins. These are 2 okay examples of coin. I have big coin and small coin. This one is from Korea. This is from China. All right. No, this is from Malaysia. Okay. This is from Korea. All right. Korea. So these 2 coins are separate object. Right. Separate object. All right. So the result of Korean coin will not influence the result of Malaysian coin. Okay. All right. Similarly, also if I throw this Malaysian coin, will not influence the result of Korean coin. Okay. These 2 coins are independent objects. Okay. So if I throw these 2 coins at the same time, then consider as independent events activity. Independent events. So far so good. Because Korean coin is not going to affect the Malaysian coin. Malaysian coin also not going to affect the result of Korean coin. Okay. So if you see the question involved, we call it throwing 2 coins question is considered as independent event question. Okay, independent event question. So let us try to check the question now. Okay, 2 fair coins are tossed. That means you throw the 2 coins. Okay. So how many possible outcomes are there? Okay, if you throw 2 coins, what are the possible outcomes? Okay, just now I haven't introduced to you. A coin consists of 2 faces only. A coin, okay, consists of 2 faces. So if I have the Korean coins, this face is considered as this one with the head, somebody's head, right? And this is we call as head, H-E-A-D. Okay, this is the head face, right? This is the head. And another face or we call as dimension is the tail. Okay, this is the tail, right? So if I use the UK coin, then the dimension that show the face of Queen Elizabeth is the face, is the head. Okay, this is the head. So I use H to represent head. Right. So what is the tail? Tail is with the dimension with flowers, with some flowers or animals. This is the tail. Okay. So one coin, a coin consists of 2 faces, which are head and tail. Okay, head and tail. Okay. So part A is you're asked to identify how many outcomes if you throw two coins at the same time. Okay, so I would like to use blue color to represent the outcome for first coin, and then the red color to represent the outcome for second coin. All right. So the possible outcome can be the first coin is head and the second coin is head. Okay, or the second possible outcome is it can be the first coin is head and the second coin is tail. Right. The third outcome is it can be the first coin is tail and the second coin is head. Okay, and the next outcome can be both of the coins show tail. Okay, show tails. So there will be 4 possible outcomes. When you draw 2 coins at the same time, there will be 4 possible combinations. Right? 4 possible combinations of outcomes, or we call it sample space. Okay, so there are 4 possible outcomes here. So in this case here, your NS for 2 dices for 2 coins question, the NS is equal to 4. Okay, NS is 4. So this is the answer. Okay, 4 possible outcomes. Okay, how about B? How many of these have 1 head and 1 tail? So now it's asking you, among these 4 possible outcomes, which outcome has 1 head and 1 tail? Okay, so you go back to here again, you check. This outcome, yes, 1 head and 1 tail, right? Included. And also this one, this outcome as well. It can be the first coin is tail and the second coin show head. So there will be 2 possible outcomes if you want to get this result, 1 head and 1 tail. Okay, so answer is 2 outcomes have 1 head and 1 tail. So this is part B. Okay. C is what is the probability of getting 1 head and 1 tail? Okay, probability of getting 1 head and 1 tail, chance. Okay, so this is your question. Okay, this is your question. So I try to translate this sentence into a formula, right? This one. Okay, so we still can apply the formula that we learned this morning, which is this one. This one, we still can use. All right, we still can use this formula. Right? So now we have to identify the NS. NS means the total possible outcomes. Just now we already identified is 4 possible outcomes. So you can put 4 as the denominator. How about the numerator? Numerator is 2 possible outcomes for 1 head and 1 tail. Okay, so we substitute the number into the formula now. So the denominator here is 4 is because of this one here. Okay, in total, there are 4 possible outcomes. So we put 4 here. 2 is because just now from part B, we know that there are 2 outcomes have 1 head and 1 tail. Okay, so we substitute 2 to the numerator. Simplify and get 0.5. Okay, so part C question actually is from your part A and part B. So far, so good, All right. Another way is if you want to answer this question, you can also try to draw a tree diagram. This is only suggestion, not compulsory to do this. It's only a suggestion for you. All right. So if you want to answer, let's say for part A, you can also try to draw a tree diagram to help you. Okay. So we start from the first coin first. First coin, you can have head or tail. So you can draw 2 branches, okay, to indicate the outcome for first coin. Okay, so first coin got 2 possible outcomes, either head or tail. All right, so this part. Then the second event is the second coin, right? So you can also draw. Okay, there will be 2 possible outcomes also for second coin. It can be head or tail. Okay, head or tail. So this part, right, these branches here, I'll refer to the second coin outcomes. Okay, then you can jot down. Okay, then you can jot down the possible outcomes combination. It can be head tail. Tail head or tail. So altogether 4 possible outcomes in order to answer part A. So for part A, you can also use tree diagram to help you. So far, so good, Okay. Now we'll move on to D now. What is the probability of getting 2 head? 2 head, easy lah. 2 head, that means we want to get P. I use P only, PR. Okay, PR. 2 heads. 2 heads. So we know that, okay, the probability value always has 2 layers. Always has 2 layers. Okay, because this question is involving 2 coins. Okay, involving 2 coins. All right. So that means the denominator is always equal to 4. because got 2 coins, all right? So it should be 4 possible outcomes, okay? Without consider whether it's head or tail, altogether 4 possible outcomes. So we substitute 4 into the denominator, okay? So now is the numerator part. Numerator depends on the question. 2 heads, okay, we check. Among these 4 outcomes, which outcome has 2 heads? Only one, right? Here, only this one, okay? Only one outcome. So we substitute 1 to the numerator. So I use in green color. So answer is 1/4, or answer is equal to 0.25. I stop for a while. Any question on example 5A? Okay, okay, now we'll move on to 5B. 5B also involves 2 events, and both events are independent events. Okay, independent events. This one already done. Okay, 5C. Okay. Okay, 5C also quite similar to 5A and B just now, but the outcomes. Okay, now we want to check 1 head and 1 tail, 2 heads. We already done. Okay, we already done this part. Okay, but the way to do the calculation slightly different. Okay, slightly different. You can refer if you want. All right, same question, but you can solve the problem by another method. Okay. Okay, now I move on to next example. It's also involve 2 independent events question. Now is throwing 2. It should be 2 dice. Sorry, it should be 2 dice. It should be throwing dice now. Okay, or 2 dice. It should be dice now. I have to do correction. Dice. Okay, so 2 dice means, okay, I want to throw these 2 dice, okay, at the same time. Okay, so if I throw these 2 dice, that means these are 2 independent events. If I throw the red dice, if I throw the white dice, the result for red and white dice are independent. Okay, the red dice result will not influence the white dice result. Similarly, the white dice result will also not influence that red dice. So that means that these 2 events, if I throw these 2, are considered as independent events. Okay, independent events question. Okay. So let us try to check part A. You are asked to list down the sample space for this question. Sample space means the possible outcomes. Okay, if you throw 2 dice, if you throw 2 dice, the possible outcome will be 36. 36 possible combination outcomes. So it's good that you can list down first the 36 possible outcome. Okay, so every time when you want to answer the question that involves 2 dice, it's better for you to list down the 36 possible outcome. Okay, so it can be the first die score 1, second dice also 1. It can be the first dice is 1, second dice is 2, and it can be the first dice is 6 and second dice also 6. So list down the 36 possible outcome. Okay, for part A. All right. So that means your NS is 36. For 2 dice question. Just now for the 2 coins question, your NS is 4. Okay, NS means the total possible outcomes. Okay, for 2 independent events question. Okay, part B. Find the probability of getting a score of 5. That means if you sum up the value for die 1 and die 2, the total value is equal to 5. That's the meaning. Okay, the total or the sum of score from die 1 and die 2 is equal to 5 exactly. That's the meaning. Okay, so in order to answer this question, it's better for us to check again from our 36 possible outcomes. Check which combination can have total score of 5. It can be 1 plus 4. That means the first die shows score 1 and the second die shows score 4. Okay, 1 plus 4 is equal to 5 exactly. Okay, another combination is 2 plus 3. Okay, or 3 plus 2, or 4 plus 1. So I use red color to circle the 4 possible outcomes here. That means for this question, the NA, okay, the numerator part is 4. So I substitute 4 to here. Okay, 4 is because of these 4 combinations. 4, so substitute to here. Okay. Then how about the denominator? Denominator, because this question involves two dice, right? Two dice. So the total possible outcomes is 36. The NS is 36. Okay, 36 is because this question involves two dice. So there are 36 possible outcomes. Okay, so this fraction number can be simplified. Is equal to 1/9. Okay, I stop for a while. Any question on this? Do you know how to get 4 and 36 here? Do you know how to get 4? I stop for a while. Do you know how to get 4? 4 is because of this, these possible combinations. Right? 36 is because in this question involves two dice. So if two dice, then there will be 36 possible outcomes. So far, so good, All right. Next example. Find the probability of getting a score of more than 5. More than 5, that means must greater than 5. The total score between die 1 and die 2 must greater than 5. That is the meaning. Okay. So what are the possible outcomes here? It can be 1 plus 5, 1 plus 6, 2 plus 4, 2 plus 5, 2 plus 6. And all these are the possible outcomes. Okay. So you count how many altogether? 26. Okay. So 26 you replace as numerator. Numerator. Okay. And how about the denominator? Denominator is NS 36. Okay, because this question involves two dice, which will create 36 possible outcomes. Simplify this fraction number, you get 13/18. Okay, so I stop for a while. Any question on independent events question? Okay, if you throw a coin and also throw a die, also considered as independent events question. If you throw a die and also a coin at the same time, then these two events are considered as independent events. So you can use the same method to solve the problem. Okay. Because a die and a coin are considered as separate entity or separate objects. Okay. So the dice result will not influence the coin result. Coin also will not influence the dice result. So far, okay? So far, so good, Okay, then move on to, actually this is the last concept that we need to know, dependent events. What is the meaning of dependent events? That means like the chance of one event will influence the chance for another event to happen. Okay, so if A and B are dependent, then the chance of event A will influence the chance of event B happen and vice versa. Okay. Depend to each other. Then we call it dependent events question. If that's the case, we have to use the conditional probability formula to solve the problem. If A and B are depend to each other. Okay. If A and B are depend to each other, then we have to use the conditional probability formula to solve the problem. Okay. So let's say if you want to calculate probability A, given that B already happened. Okay. Probability A, given that B already happened, then what is the formula? If A and B are dependent, then the formula is equal to probability A intersect B divided by probability B. Okay, because A is depends on B now. So you have to use probability B as the denominator. Okay, B has to be used as a denominator. If B is at the back, then you have to use B as the denominator. So similarly also, if you want to calculate probability B, given that A already happened, given that A already happened, then the formula for denominator should be A. A had to put at the bottom part as a denominator. And then the numerator is probability of B intersect A. So bear in mind, A intersect B is equal to B intersect A, same meaning. Okay, even though you may find that the sequence is slightly different, So, but no matter how, okay, no matter how, in what type of, whether it's independent, dependent, mutually exclusive question, A intersect B, is the same meaning as B intersect A, same meaning. I use symbol, all right? I try to use symbol. I simply use n, all right? Or maybe I use equation, right? I use equation. A lot more standard. This one, okay? B. Same meaning as this one, huh? Same meaning, okay? A intersect B means B intersect A. Same, huh? However, okay, this one I better put somewhere else. This is same meaning, all right? However, you cannot say that property A given B always equal to B given A. It's not always, so I better put symbol. Not equal, this one, okay? Okay. Property A given B is not always equal to probability B given A, different meaning, okay? But A intersect B is equal to B intersect A, okay? Okay, and besides that, right, if the two events are dependent events question, then it's better for us to use the tree diagrams and also the joint probability table to help us to solve the problem for dependent events question. So some students may ask, can we use tree diagram and also the joint probability table to solve the independent event? Yes, can. Okay, but for dependent event, then tree diagram and joint probability table will be more useful for us. Okay, so let's try one example. This one, okay. Let us analyze the case study together, right? So this question is, three companies, which are A, B, and C, are competing for a contract to build a condominium. Okay? So that means this is the first issue, the first event. First event means there are three companies trying to compete each other in order to get a project to build a condominium. Okay, so this is first event. So if I want to analyze, I can put here some short note. I can say this one, it can be event one. This is not compulsory. I just put here. This I can say is competing for a contract, right? I just copy this. Competing for a contract. So this is event one. I use some maybe light blue color. This is only to make us understand better about the case. Okay. And then we know that there are three companies trying to compete among each other. Okay. Okay, then okay, I can try to also this one I delete for a while. Maybe I copy this, duplicate the slide. Okay. Because we need to understand the meaning of this case study first before we answer the question. So if I draw the tree diagram, that means the first event here I can try to draw three branches, okay, with three branches, because we know that there are three companies trying to compete with each other. I use black color, all right? This is only a draft, only a draft. I use insert. We haven't answering the question yet, but I just try to draw a diagram to show you the meaning of this question, all right? So this branch is for company A to compete. This one is for company B. This is for company C. Okay. So I try to just do a draft only. Okay, next. If you want, you can also put the text. All right, text. Because this is only a draft, we haven't really confirmed. Okay, I put a text box. Okay. Put here. B. C. Okay. The next sentence, let us analyze together. Okay. The probability that companies A, B, and C will win the contract are 0.25, 0.45, and 0.3 respectively. Okay, what's the meaning? That means that the chance for company A to get the contract is 0.25. Probability for company B to win the contract is 0.45. Okay, and probability for C to win the contract is 0.3. Okay, so here I just put event will be win a contract. Win a contract. Okay, so this second sentence actually I can try to translate into mathematical equation from the second sentence. So I can say that the PA is equal to 0.25. Okay, from the second sentence. And then B is 0.45. So I can say that. The chance for company B to win the contract is 0.45. C is 0.3. Okay, if you check, right, if you sum up, right, the three branches probability value, you may find that is equal to 1 exactly. So if the branches are from the same point, the total probability value must always equal to 1 exactly. This is the way you check your answer. 0.425 plus 0.45 plus 0.3, you may find that is equal to 1. Okay, because these three branches are from the same point. So the total probability value is equal to 1. Okay, so that means that company A has 25% to win the contract. Company B has 45% to win the contract, and company C has 30% to win the contract. That's the meaning. Okay. Okay. Next sentence. If companies A, B, and C won the contract, the probability that this company will make profit are 0.8, 0.9, and 0.7. Okay. So this sentence will tell us the second event is make profit. Okay, make profit after winning the contract. Then the company may make profit or make a loss. All right. So the second event is referred to making profit or making a loss. Okay. So I just put make profit. Okay. Profit, as the second event. Okay. So the sequence of the event is very important. Sequence is very important in this case. So by logic, right, a company must get the contract first before can decide whether it's making a profit or loss. So the first event, it should be win the contract first. Second event is whether the contract can generate profit or loss. Okay, this should be the second event. Okay, so based on this information, okay, I can try to draw the information for second event as well by using the tree diagram. So I try to use this. Okay. So making profit can be either there'll be two possible outcomes also for making profit. Either making a loss or making a profit. Okay, so if the company A won the contract, right? So the company can either make a profit or making a loss. Okay? For B also the same, profit or loss. So I try to copy the branch. Okay, we call this is a branch to company B. For company C as well. Now it's only doing a draft. Okay. So what is the meaning of this branch? What is the symbol we can use to represent this branch? Okay, I copy this. Because this one, this branch, okay, maybe I can use other color I use other color. Okay, because this branch is based on property A, so that means A had to put at the back because when A happened first, okay, A happened, so you have to put at the back. All right, and then for making a profit, maybe you can use one symbol to represent making a profit. Maybe I'll use D D means making a profit. Okay, given. So for this branch is referred to property for company A to make a profit given that company A is able to get the contract. And that is the meaning. Okay. Then how about the equation for this branch? This one is property. Company B will make a profit. Okay, D means profit. If the company B is able to win the contract, so we put B at the back. Okay. So this B is referred to the event one, the first event. Okay. Then how about this one, this branch? This one, because this branch is depends on C, so we put C at the back. So this branch should represent property of company C make a profit if company C is able to get the contract. Okay. So now you may ask, then how about the title for the remaining branches? Okay. For this one, because we know that for the second event, there are only two outcomes, either making profit or making a loss. So for making a loss, we can use D bar. Okay, we can use D bar to represent making a loss. So this one I can change to D bar. I can use this symbol, D bar. This is A. So I try to stand by first, all the equation that we need. Okay. And for this branch, because it depends on B, so B should be put at the back. For this one, it depends on C, okay? So C should put at the back for this branch. Okay, so this is how you draft your tree diagram, something like this, all right? So now we can also fill in the blank for the figure that we managed to get from the question, all right? So this one means that if means something already happened, if. So I use blue color. If companies A, B, or C won the contract, and the probability that this company will make profit 0.8, 0.9, and 0.7. What's the meaning? That means that for this equation, the answer is equal to 0.8. Okay, it's from here, 0.8. How about this one? The figure is 0.9. Okay, it's from here, these numbers. This one is equal to 0.7. Okay, so now you may ask, then what happened to these 3 branches? The figure are not given, right? Not given. So how do we calculate probability D bar given A? Okay, because we know that these 2 branches are from the same point, right? From this point. So as a result, the total probability value of this branch and this branch must always equal to 1. Okay, so if this one is equal to 0.8, then this branch must equal to 1 minus 0.8. So you get 0.2. Okay, so 0.2 is using 1 minus 0.8. Then you'll get 0.2. Okay, 1 minus 0.8, you get 0.2. Okay, then how about this one? Because these 2 are from the same point, so as a result, the probability for this branch should be 1 minus 0.9. So I get 0.1. Okay. How about this one? This one should be equal to 1 minus 0.7 because these 2 branches are from the same point. So it's 0.3. Okay. So now we just try to draw a graph before we answer the question. Okay. At least we have some idea on what happened for this case study. So far so good. Do you have any problem with this one, with this figure that I highlight with different colors? So far okay? And also the way to put the symbol. So far okay? So if this branch is influenced by A, then A you have to put at the back. For these 2 are influenced by B, so B you have to put at the back. Okay? These 2 are influenced by C, so put C at the back. Okay? Okay, now we can start to answer the question. First question is, okay, you're asked to construct a tree diagram based on the above information. So how to construct a diagram? So at first is you have to put a symbol, use a symbol to represent the meaning of each event. Okay, so you can use A. Let's say you can say A is equal to company A wins the contract. Okay, B is company B wins the contract. C is equal to company C wins the contract, and then D is referred to company makes profit. Right? Because companies make profit, the company can either make profit or making a loss. There are only 2 possible outcomes. So D can be equal to company makes profit, and then you can use D bar to represent company not making profit, okay, or making a loss or not making profit. Okay, you can use D bar to represent this as well. So I use the symbol of this, right? D bar. This one you can just follow the pattern of the question. So company does not, okay, profit. This is making a loss, right? So you put the symbol first, you put the symbol first for each event, right? Then the next step is you try to draw for the first event. There will be 3 possible outcomes. Right? First event is about company wins the contract. So you try to draw 3 possible outcomes. And then second event, there are 2 possible outcomes, either making profit or making a loss. Okay. So you can try to jot down the information given and plus the figure as well. Yeah. All right. So once you have this, actually you can calculate the A and D probability. Okay. So what is the meaning of A and D? That means A intersect D. A intersect D will be equal to 0.5 and 0.25 multiplied 0.8. So you'll get 0.2. If the question is asking you to calculate probability A intersect D, then you can use probability A multiplied with probability D given A. So how to get this formula from? Is from here. Okay. It's from this formula. So if you ask to calculate A intersect B, you can just transpose the formula. Move the probability B to the left-hand side. Okay. If you want to calculate probability B intersect A is also equal to probability A multiplied probability B are given as same meaning. Yeah? So the formula are from here. So you can get ready first the information given if you want, in order to answer the remaining question later on. So this is for part A. Okay? This one no need to put. The purple color, this is the orange color one, no need to put. Okay, no need to put this. This one no need. Okay, this one also no need. It's just for your information only. No need to put. If this one you don't put, it's also okay. Only need to focus on this part and also the meaning of each symbol. You need to put for part A. So far, any question on how to draw the tree diagram? Okay. Then part B. Part B, what is the question? Part B is, okay, you are asked to calculate what is the probability the companies will make profit. Okay, will make profit is about the second event. Okay, it's all about the second event, right? Make profit. So it's about second event. Okay, so in order to answer this question, you have to go back to the tree diagram that we already drawn. Okay, you check among these so many pathway or any branches. We call it pathway or branches. Any pathway that consists of profit or not, anything that related to profit, yes. This one got D, right? I use a green color. This one got D. Okay. Okay. And this one is D bar. No, we don't want to include this. Only the pathway that consists of D. Profit one. D. Okay. So in order to make profit, it can be either company A won the contract and make profit. It can be from this pathway, the first pathway, or it can be from pathway B, okay, which is 0.45 multiplied 0.9. Or it can be from pathway number 3, is from company C, using 0.3 multiply 0.3. Okay, so the answer is 0.25 multiply 0.8 plus 0.45 multiply 0.9 plus 0.3 multiply 0.7. Okay, so 0.25 multiply 0.8, you'll get 0.2, so substitute to here. Okay, the second possible outcome is from here, 0.45 multiply 0.9, you'll get 0.405, so substitute this number to here. Okay, the third pathway is 0.3 multiply 0.3, you'll get 0.09. So 0.3 multiply 0.7, you'll get 0.21. Substitute this number to here. Okay, so simplify, you'll get 0.815. So that means that 81.5% the project can get a profit. 81.3% the project can get a profit. Okay. So if the question is asking about the event 2, the event 2 probability, then you can use this method, okay, to solve the problem. So usually I highlight also, like I can do in this way also. Okay, I just do like that. Also okay. You can just highlight this. This is the first pathway plus the second pathway plus the third pathway. Okay. So this is for part B. Part B will use this method when the question is asking for probability of second event happen. Okay. So you need to consider the first event probability as well. All right. So the third question, what is the question? Let me see. The third question is, if the contract is found to be profitable. If is the keyword. If, that means something already happened. If something already happened. Contract make profit. Okay, this is profitable. Maybe I use green color. Right? So something already happened. It's profitable project. Okay, it's profitable. So that means profitable, the D we have to put at the back. Okay. So this question, we have to put D at the back. It is already given to us. So I put D at the back. I use green color. Okay, profitable. Find the probability that the contract was given to company A. So that means now you're asked to calculate probability A. Maybe I use blue color, right? Company A. If the contract is profitable. So what is the meaning of this sentence? That means you are asked to calculate probability A given D. And that is the meaning of this question. Okay? You are asked to calculate this one. Probability A given D already happened. So far so good. And this is the question that you need to solve, huh? So I copy this. To here, all right? Because we know that these two events are the A and D are dependent events question. Okay? So as a result, you need to use the dependent event question formula to solve the problem. All right. So what's the meaning of this one? This one means A intersect D, yeah, because D is at the back, right? So you put D at the back, okay, divided by PD, yeah, because D is already given. So D should be used as a denominator. Okay, so the formula actually is from here. Okay, from here, from this formula. So if D is at the back, that means D should be used as the denominator. Okay, so now we have to substitute the number into each variable. So A intersect D, where can we get A intersect D? This one. A intersect D is this one. 0.25 multiplied 0.8 equal to 0.2. So we substitute 0.2 to here. A intersect D is here. N means intersect. So substitute 0.2 to here. Okay. Okay, how about this part? Denominator. Probability D. Do we have the answer? Yes, we already obtained the answer in part B just now. Here we already have the answer. So we substitute this number, okay, exactly this value into the denominator. Okay, so simplify, you'll get 0.2454. You may round the answer to 4 decimal places. Okay, so far so good for dependent event question. It can be new for you, huh? Maybe in your Form 5 you haven't studied this dependent event. It's a new thing for you. Okay, one example is not enough. Let us try another example. More simple one, all right? Okay, this is also dependent event question. So let us analyze together. The probability that Melinda takes tuition for statistics is 0.3. Okay, what's the meaning of this sentence? That means like the chance for Melinda to attend statistics tuition is 0.3. Okay, so that means the chance for Melinda not attending the tuition is 0.7. That is the meaning. So I try to, okay, so based on this question, I can try to draw something first, all right? Draw something. So this I delete. So I can say that event number 1 for this question, event 1 is attend statistics tuition. Or we can just put tuition. Event number 1. Okay. Use blue color, right? Okay. Besides that, I can also try to draw a draft only. It's a draft. I know that. Okay. First event consists of 2 possible outcomes: attend or not attend. So I can try to draw 2 branches. Okay, for the first event. I can also use some this we call a symbol to represent this. So maybe I can use A to represent attend tuition. Attend tuition. Statistic tuition, right? Attend tuition. If that's the case, that means A bar is not attend tuition. Okay. I use this symbol. Let's put not attend tuition. Okay. And from this sentence also, I can start to write down the probability value as well. Just a draft, no need to show to the examiner, just for our own reference text. Okay. Oh. I try to insert the box so they can write down something. Okay. So PA is equal to 0.3, yeah? And probability non-A is equal to 0.7. So this one I change to non-A. I can use this symbol. To 0.7. So far this is what we have from first sentence only. First sentence. Okay, next sentence. If Melinda takes tuition, that means if A already happened, if Melinda takes tuition, the probability that she will pass the statistics paper is 0.8. Okay, next sentence. If Melinda does not take tuition, the probability that she will pass the statistics paper is 0.6. Okay, so from this sentence, we know that the second event is about either passing or failing the statistics test. Okay, so here I can put pass statistics test. Okay. So you can see the sequence is very important. Sequence should be attended tuition. Second event should be either pass or fail the test. Okay, so test is the second event. The test result second event. Okay. So if there's a case, I can put B. B means I can put. You can choose a symbol. You can use C, D, E, F. It's up to you. I'll choose B. So B, I can say pass the test. I just say pass. All right. So if B is pass, that means B bar is not pass. So I just put not pass. You can put fail if you want, or I can just put not pass. The statistic test. Okay. So this one I use smaller font so they can have more space later on. Okay. So from this information, we can try to draw the branches for the second event. So I draw first. All right. A few more lines. So this is black color. I copy this. Put here. Okay, then we give this equation for each branch. Okay. Copy this. Okay, for this one, you may find that right, it depends on this result. Okay, it's A, depends on A. So we put A at the back. Then in front, what should we put? Because just now we use B to represent pass, huh? So you can put B, okay, pass, okay, given that Melinda attended the tuition, okay? So it's this symbol. How about this branch then? This one is also from A, right? So you have to put A at the back. Okay, put A at the back. But this one you need to change to B bar. That means not pass. Then how about this one? This one is B given A bar. So this one I need to change to A bar, huh? Because this branch is rely on this one, okay, the result of the first event, which is A bar. Okay, last one is this, that means it's probability not pass, given that Melinda does not attend tuition at all. So I can use this one. This one change to B bar, huh? So now I have to fill in the figure. Okay, the figures, huh? Okay, so we start from this sentence, huh? If Melinda takes tuition, that means A, if A already happened, the probability that she will pass the statistics paper is 0.8. So what is the meaning of this sentence? Actually, this is referred to this one. Okay, it's referred to this bunch. If Melinda already attended the tuition, what is the probability that she already passed the statistics test is 0.8. Okay, so it's this one, 0.8. Okay, last sentence. If Melinda does not take tuition, so it's A bar, right? Does not take tuition. So you have to check A bar, this one, A bar. Okay, the probability that she will pass means is B, yeah, is 0.6. So it's referred to this, okay? Refer to this branch, 0.6. So I stop for a while. Are you okay with these two numbers? So this one is from second sentence, okay? This figure is from the third sentence. All right. Okay, now there are two branches, the figures are not given, right? Not given. Okay, so how are we going to find out the figure in order to solve the problem later on? Okay, because these two branches are from the same point, right? From the same point. So that means like if these two probability value sum up together, it should be always equal to 1. Okay, so this one should be equal to 0.2 lah, right? Which is 1 minus 0.8. 1 minus 0.8, you'll get 0.2. So I use red color. I use red color. This one maybe I can use green color, pass. Okay. Okay. Then this one should be 0.4, using 1 minus 0.6. So I get 0.4. Okay. So this one I use red color, and then this one I use green color. So this is only a draft only. Yeah, we haven't really answered any question, but you have to prepare all this information before you answer any question. Okay, so sequence also very important. So for this, there are two events. So the first event should be attend or do not attend tuition, right? Second event is pass or not pass the test. Okay, so this is only a draft. Okay, let's start to answer the question. So part A is you're asked to construct a tree diagram based on the above information. So in order to draw the diagram, first step is you try to choose an appropriate symbol to represent the event. Use appropriate symbol. All right. So yeah, in this case, I use T and A. So you can choose the symbol. Choose the correct symbol. Don't choose P anymore because P already used to represent the probability. You can choose A, B, C, D, F. All are okay. All right. Then you try to draw the diagram, okay, and put the equation plus the figures, okay, plus the figures. Okay, so far so good. Okay, part B. Let me see what is the question now. So if you are able to present this, is okay already, sufficient already. Okay, for this part, put the meaning, indicate the meaning of each symbol, and then draw the tree diagram plus the equation and value for each expression or each branch. That will be okay. Yeah, you can get full mark already. Okay, part B. Find the probability that Melinda passes the statistics paper. So this question is asking about second event outcome. Second event, okay, pass the statistical paper. Okay, so I use green color. Okay, so now is you have to go back to your diagram that you had drawn just now. I use this diagram, right? Okay, I'll check any pathway that involve pass the statistics paper. Yes, here, right? This one and these two, right? But these two outcomes are depends on the first event. All right. So if I want to calculate the probability, okay, this I insert the text again. I insert the text. So this is P, all right. Pass the statistics. So in this case, I use B, all right, B, pass, okay. PB, you're asked to calculate the PB. Okay, so you need to identify any pathway consists of PB. So we know that is 0.3. Multiply with 0.8. This is the first outcome. Second combination can be 0.7 multiplied with 0.6. Okay, I use green color to indicate this pathway here. This one here. Okay. This one maybe I can use blue color so you can see the figure. This question is asking about the second event probability value, but second event is depends on first event as well. So you need to consider the first event probability as well. So these are the two possible pathway in order to pass the statistic test. All right. Then you simplify this expression. Okay. This one you get 0.24, right? This one you get 0.42. Okay. 0.24 plus 0.42, you get 0.66. So that means 66% Melinda can pass the statistics test. Okay, 66% this Melinda is able to pass the statistics test. Okay, that's the meaning. Okay, C, what is the question? Find the probability that Melinda takes tuition. Takes tuition, just now we use tuition just now we use B, huh? We use no A. We use A to represent A. Huh? If she passes her statistics paper, what is the meaning of this sentence? How are we going to translate this sentence into a mathematical equation? Keyword is this one, if. If. Okay, if already pass. So that means, right, this variable, the pass, the statistics, should be put at the back after the dash sign. Okay, have to put up at the back after the dash sign. So this one means if I try to write down the equation, dash sign is the if function. Okay, passes is pass we use just now is using B, right? B pass. Okay. I think I use green color. Okay. So how about in front? What is the variable that I have to put? Okay, this one. Find the property that Melinda takes tuition. Takes tuition just now we use A. Takes tuition. So I put A in front. B which put at the back is because of this word. If. Okay. If she passes the statistics paper. So B had to put after the dash sign. Dash means the if symbol or given symbol. So this is the meaning of the question. Okay. So next is we need to convert the conditional formula into the intercept formula. So what is the meaning of this? This one means PR A intercept. So intercept we use something like N, right? Okay, I use this symbol. This one, and then intercept with B. Okay, because B is at the back, so we have to put B at the back as well. Divided by probability B. This depends on B now. For this question, okay, for this part C question, so B you have to put at the back, because B, this B is after, appears after the if word, so B had to put at the back. If she passes her statistics paper, already passed, okay, B, all right. So now is we need to use the tree diagram just now to help us to get the value now. We need to get the value now. Okay, so I copy this one. And then I'll paste to the diagram that we already drawn just now. Okay, I better use this one. C. Okay, we want to answer C now. I do one more time. PR just now is A given B. Okay, so let us try to insert, right, or just put the symbol or the figure for each variable. Okay, A intercept B. Where can we get the information? A intercept B. Yeah, 0.3 multiply 0.8. Okay, 0.3 multiply 0.8 is referred to A intercept B. 3 multiply 0.8. Okay, 3 multiply 0.8. So maybe I can use blue color to represent this. Green color is here. Huh? This one. Okay. Then divided by probability B. Probability B, yeah? Okay. B is referred to the second event answer. Have we found the answer? Yes. In part B, you already get the answer. Yeah. 0.66. We already have the answer. The pink color one. Okay. I use pink color. We already have the value. Yeah. So what can you do is you can just substitute 0.66 into the denominator, this part, the pink color. Okay. This one. So put 0. Okay. Then we simplify it. Yeah. So answer is equal to what value? You should be equal to 0.36. Okay. 0.36. Okay. So in short, if the question involves two dependent events question, so it's better for us to use the tree diagram to help us to solve the problem. Okay. So any questions so far? So far so good, Okay. Besides tree diagram, we can also use the joint probability table to solve the question that involve dependent events question. Okay, so I'd like to show you one example now, like this. Okay, so this question actually is referred to the marital status and also the age of participants. So in total, there are 140 participants involved in the survey, all right, to indicate the marital status and also the age. So marital status can be divided into either single or married, and the age is under 30 or 30 and above. Okay, so this table already given to us. Let's say, assume that this table already given to us. Okay, so based on this table, you are asked to calculate the probability of a customer who is single and under the age of 30. Okay, under age of 30. Yeah. So that means your equation is single and under age of 30. So since you already have the table, it's easy for you to solve the problem. Since you already have the table, it's easy for you to solve the problem. Okay. As we know, the probability value always in two layers, right? So the denominator here is referred to the total number of people or customer who involved in the survey. So altogether 140, right? So you substitute this one 140 as the NS. Your NS is put here. Okay, NS. So now it's NA, we don't know, right? NA, single and under 30, must fulfill these two characteristics, single and under 30. Okay, so what you can do is you go to single row and go to the under 30 column. So the intersection value is 76, right? This question must fulfill the two characteristics, single and under 30. Okay, so we go to single row, go to the under 30 columns. So the intersection cell is 76. So we substitute this number, 76 people. That means 76 customers are single and also under 30 years old. Okay, so we substitute 77 as the numerator here. Okay, so simplify this. You may round the answer to decimal number if you want and round to 4 decimal places. So you get 0.55. Easy, this question? Easy for you? So far so good, Okay. B. This question is, if a customer is under 30, that means that given, we know that that customer is under 30, okay? So we put under 30 as the denominator, we put at the back, okay? If, this is the keyword, if, given something already happened, okay? Given. If customer is under 30. So this one maybe I can use, this color. Maybe I can use other color. Otherwise, you cannot see the whole picture. I use other color. Any other color that we can use? Okay, I use pink color. All right, pink. If 30. Okay, pink. So this is under 30 here. Okay. So that means under 30 you have to put at the back after the slash symbol. Okay. What is the probability that he or she is single? Okay, so single you have to put in front. Okay, single put in front. So this one I use green color. Okay. Under 30 you put at the back, because this word comes after if. So put at the back. So this is the conditional question. Okay, conditional question. So far so good. All right. So what is the meaning of this equation then? This one means I can add one more step. I can add one more step. This one means PR single intercept under 30. Intercept we use N, all right? Under 30. Divided by probability under 30. Okay. Single under 30. Okay. So this equation means this one. Okay. If I try to extend is this one, because age and marital status are dependent event. Okay. So this is the meaning. Okay, so now we want to solve the problem for numerator first. Numerator is single and under 30. Single and under 30. Okay, we know that single and under 30 is 77 people. Okay, fulfill these characteristics. 77. So we substitute 77 into the numerator, this part. Okay. How about the denominator? Probability under 30. Under 30 altogether we have 91. Okay. If we don't consider others, only consider the under 31 altogether, we have 91 of them. So substitute 91 to here. Okay. So simplify. In fact, this one is 77 over 140 and 91 over 140. But because 140 can be compensated, we can simplify. So we can skip. 140 no need to write down anymore. For both numerator and denominator. Right? So simplify. 77 divided by 91, you'll get 0.846. Okay, so this is how you get the answer, by applying the dependent event formula. So far, so good. Do you know how to get this 91? 91 is because in total, there are 91 customers who are under 30 years old, okay, which is this part, the denominator. Okay, all right. I think it's last example. Okay, last one, I think should be the last one. Got some more. Oh, a lot. Okay, we still have about 10 minutes. Okay, we can try again. Okay, this question. This is another question. I think maybe we can discuss by tomorrow. We still have time. All right. I think it's already adjusted. 10 minutes. Yeah, this is another question again, another example. So tomorrow we can discuss. Okay, we can discuss the last example by tomorrow. It's also using the joint probability table concept to solve the problem. Okay, we can discuss tomorrow. And so that means that at the moment you should be able to do the tutorial chapter number 2 questions already. Tutorial 4 chapter 2 number question. So if you want to get the tutorial question, you can just go to our Canvas site. All right, I'll show you how to get the tutorial questions. You can try to start to do some already. Yeah, I understand that this probability concept can be new for all of you. So yeah, it may need time to digest. So the tutorial question already posted on the week 4 module. Under the week 4 module, you can go to here, to tutorial week 4 tutorial. Okay, and then just open the questions. So at the moment, you should be able to try all the questions already. Okay, you should be able to try some of the questions already. All right. So this section consists of 3 parts. Okay, First part is to test your understanding on one event question. One event question will be first part, section 2.1, right? 2.2 will test your understanding on independent events question, like throwing one coin, one dice, throwing two dices, throwing two coins. Okay, test your understanding on this, right? And then exercise 2.3 is to test understanding on the dependent events question by using tree diagram and also the joint probability table. Maybe tomorrow we can also go through one question is on choosing balls from a box with replacement question. Choosing two balls one by one with replacement. That will be under the dependent event as well. Okay, so we can also discuss tomorrow. So at the moment, you should be able to to solve most of your tutorial, the chapter 2 tutorial questions already. Okay. And another one is, okay, your test, your test. Okay, your test one, will cover until this chapter. Will cover until chapter 2, until this chapter. Okay. That test will be 20%, okay, of your overall marks in this entire semester. Will be conducted on the 8th of November. It's from 10 to 11 Malaysian time. We are going to use our lecture time. That means our Monday time will be used as the online test one. Okay. I'm going to show you also how to attempt the test one. All our multiple choice questions, 20 questions, okay, altogether. All our multiple choice questions, no need to show working at all. Okay. Each question consists of option A, B, 1, 2, 3, 4. Maybe I can show you now, but I haven't completed the question design. Let me have okay, maybe I can share with you now. I'm going to pause the practice exercise question for you to practice, okay, probably by today, because I still want to improve the question first. This is only for your practice. The format of the question will be similar to your online test question. Let me see. Practice exercise. Yeah. Okay. I'm going to pause it by this afternoon. Okay. I want you to see the questions. Something like this. All right. Like this. Okay. When referring to a curve that tells off to the left, and you call it as what? Symmetrical, skewed right, positively skewed, none of the above. Okay. If you think that this answer is correct, then you just take. Let's say if you think this is correct, okay, then you just check this answer. Take this. Then continue the remaining questions. Okay. So each question consists of 4 choices. You have to choose the best answer. So 1 question, 1 mark. Altogether, 20 questions. You have to answer all this within 1 hour, 60 minutes. Okay. Probably I can discuss with you again during the next lesson. Maybe tomorrow we can discuss again. All right. So I think, yeah, before we call a day, okay, 3 more minutes to go. I think I have to stop recording because some of the students request me to pause the recorded video after the class. So let me stop recording. Okay. All right. Today is a long